Hello. Hi, okay. Welcome if you're here. I think we're live now. Feel free to message in the chat as well, because I can see your comments coming in. So welcome if you're here. We're going to look at SUVAT today. I hope everyone's keeping well. So this is another live session on some of the A-level maths content. So welcome. Good, excellent. Thanks to those that have commented already. I'm going to share my screen now and we're going to look through some of the SUVAT style questions from the A-level maths. Okay, so here we go. Let me just get ready to share this and do let me know that you can see it. So hopefully you guys can all see that, and hopefully I've moved up to the top corner. Do let me know in the chat though. Excellent. And here we go. We're going to start with this. So we're going to look at SUVAT today. I'm just going to get the laptop set up so I can write on it. And this is a big topic in the A-level maths, in the mechanics part. You may well have seen this in physics as well. For those of you that take A-level physics, you may have perhaps seen it even at GCSE. So this is to deal with constant acceleration. It's a kinematics type subtopic. So SUVAT deals with acceleration and those kind of motion problems. So we're going to look at, these all stand for something. So S, U, V, A, and T. And we're going to just kind of look at some questions here today. So excellent. If you're familiar with this, as I can see from the chat, some people are. Thank you for a little reminder on what each of those things mean. So we're talking about displacement, initial velocity, final velocity, acceleration, and time. Okay, and there's some SUVAT equations you're going to really need to know. So I'm hoping in general this might be a bit of revision for some people. Some people you might not be too familiar with the SUVAT equations. Depending on what exam board you're doing your A-level with, will depend whether they give you these equations. I think some of them do give these in the formula book, but in all honesty, it's worth knowing them. And if you know the SUVAT equations, then you've certainly done a fair bit of practice. So that's the kind of level we all want to be at. But we're going to look at some actual exam style questions here today. And feel free to comment, ask questions, and double check anything as we go. So we're going to be looking at SUVAT. There is going to be a coupon code for all at the end. I'm sure you're aware that we do this. So if you stay tuned, there'll be a coupon code at the end of this session that will allow you to get a discount on Snap Revise on our platform. So it's probably been a while since some of us have been at school. It could have been a long time since you've seen this. Maybe you never actually covered this yet before the school shut, but this is an important topic, and it forms a really kind of crucial part of the mechanics side of the course. So this is applicable for all exam boards. This is something, a really underlying skill that we need to know for mechanics. So we're going to move on to some practice now. Cool, here we go. So here's an example of a SUVAT style question, and I will read it out in case my screen is blocking it a little bit. My face is in the way, but I'll read this to you and then we'll work through what we know. Feel free, as always, to work ahead of me and, you know, as I said, practice and try and get to the answer first, but we'll talk through it anyway. So a train moves along a straight track with constant acceleration. That is actually the key word telling us we're going to need SUVAT. Okay, so there is acceleration, but it's a set value that we're going to call A. 3 telegraph poles are set at equal intervals beside the track at points A, B, and C, where AB is 50 meters and BC is 50 meters. The front of the train passes A with speed 22.5 meters per second, and 2 seconds later it passes B. Okay, so some key bits of information there. So as I said, the bit that's telling us it's SUVAT is the constant acceleration. And what I would often do is actually write down the SUVAT letters, S, U, V, A, and T, and determine which ones we have and which ones we need. Okay, so we're looking for the acceleration This is what we want. We know time. We've been told that it's 2 seconds. We know, what else do we know? We know u. We know the initial velocity is 22.5. Lovely, well done and well suggested. Thanks for the comments there. And we are actually looking for the acceleration. Do we know anything else? Yes, for that part of the journey from A to B, what else do we also know? So we know it's taken 2 seconds. We know they started at a speed of 22.5 meters per second. We're looking for the acceleration, but there is one other thing that we also know. And what is that other thing that we're given in the question? And we're dealing with the motion from A to B specifically, so that we can use all of these different parts. It's constant acceleration, super. And there's one other value we're actually told in the question. A value for what? What are we given here? Lovely, S is 50. We're given the displacement from A to B. So what we've got is we've got a SUVAT equation that involves S, U, A, and T. And generally, with any of these questions, there's obviously the 5 different things there. And generally, the question concerns 4 of them, where one of them's unknown, 3 of them are given, and the other one we don't really care about for this question. So what we do is the SUVAT equation we would need to use here is the one that involves S, U, A, and T. And that is S equals UT plus a half AT squared. I think that's what this question is lending itself to using. And we can sub in the values and solve. So S was 50. So 50 equals U, 22.5, times T, which was 2, plus a half. A, we don't know, so let's just call it A, times T squared, 2 squared. There we go. Okay, and if we solve that, so we're going to sub our values in, tidy that up and rearrange for A. So we're going to have 50 equals 45 plus 4 times A over 2, so 2A. So A is equal to, and well done if you've got there ahead of me there, 2.5, and our units are meters per second squared. So it's meters per second. It's the rate of change of velocity with respect to time. So do remember that as well. So a nice kind of method and answer mark there, and then a final answer mark, and that's your 3 marks. Okay, very well done if you got that. It's great to see so many of you kind of working ahead with this. Brilliant, good, and do remember your units. Lovely. Cool, right, let's move on. So this question here, so it's an extension, a continuation of the same question, and a good question there. Do we need to memorize? So as I mentioned earlier, some boards do give you the SUVAT equations. I would strongly suggest, yes, you do learn them, because actually it's really good if you can derive them. I have seen that kind of come up before, that they asked, how does this one relate to this one? Can you rearrange the SUVATs and so on? If you've learned them, I think the good way of thinking about it is you've done a lot of practice then. So yes, I would strongly advise that you learn these so that you can just get straight away started with the question. Okay, so I hope that answers the question. So carrying on for part B, it says the speed of the front of the train when it passes C. Okay, so when it passes C, remember the equal intervals of the telegraph poles are 50 meters apart. So we now know the acceleration. So I'm going to set this up, S, U, V, A, and T. And let's fill in what we want and what we know for the entire motion from A to C, because we want the speed that it's going at C. Okay, super. S is 100 meters because we're going from A to C. And because we've set it up from A, we can still use that same initial speed, initial velocity, so 22.5. So very well done if you spotted that S is 100, because that's kind of the little bit that's maybe a little bit hidden in the question. Brilliant. U is 22.5, lovely. A is going to be the value we just found. So what was that? That was 2.5, wasn't it? So A is 2.5. And what are we looking for this time? Well, we don't really care about the time that it passes C. We care about what its speed is doing, the final velocity. And excellent, well suggested there. The SUVAT equation we use here is V squared equals U squared plus 2AS. So if you haven't done SUVAT before, you might not know which one to use here. Other points that people are raising as well, you can find other things, like you could find the time and then find everything. Be careful not to make too many assumptions with the time though, because we're now not looking from A to B, we're looking at from A to C, and we haven't been given the time it takes to reach the telegraph pole at C. So it's very important we're careful there. So subbing these values in, V squared is the unknown, or V is the thing we're looking for. So we're going to do 22.5 squared plus 2 times 2.5 times the displacement, which is 100. And I believe that, so we can work that out, square root, and we get V as equal to 31.7. And then we need to look at our units, which was meters per second. Right, so well done. Just keeping an eye on the chat because there's some really interesting points coming in. Some people are asking if you can use differentiation. I think that's what we're suggesting. Or no, not differentiation. Some people are saying distance over time. Right, this is where we need to be really careful. So the final kind of part of kinematics is using calculus, so using differentiation and integration. And that's when acceleration is not constant. When acceleration is constant, you need to be looking to use SUVAT. We can't just use speed, distance, and time, because that whole average speed equals distance over time thing is for when there's no acceleration going on. When there's acceleration going on, the speed is actually constantly changing. So you can't really say a set speed because it's not going at a set speed. So that's why SUVAT is really important. So we've got to be very careful there. But some excellent comments, questions, and ideas being teased out in the chat there. So thanks very much for kind of responding well to this, and do keep the questions coming in. So hopefully that's clear how I've arrived at 31.7 meters per second there. And obviously I've rounded that, I've given it to 3SF. So maybe I should say that might be a good idea. If the question doesn't state, if you state how you've rounded it, then you're kind of covered. But do also check the rubric on the front of your exam, because sometimes it tells you if it isn't stated for mechanics that they want you to give it as 3SF. So do look out for that, because that could vary from board to board. But yeah, make sure you show your full working and you'll get all your method marks as well. Okay, lovely. So let's keep going, because I think we're doing really well here. At time t equals 0, a particle is projected vertically upwards with a speed u meters per second from a point 10 meters above the ground. At time t seconds, the particle hits the ground with speed 17.5. Now, this is a projectiles question, but it's all happening in a vertical sense. So this style of question gets a lot more difficult and involved maybe in the year 13, where it's been projected at an angle. But a straight up and down motion is just SUVAT, and we're looking at using gravity to deal with some of the acceleration that's going on. We have to be very careful here. And I think from what I can see in the chat, we're picking out the kind of crucial point here. What are we using as displacement? I've got to get my negative signs right. And this is absolutely correct. We do need to be very careful. So the way I would suggest we do this is we set a positive direction, and we can kind of decide that. Okay, so the way we could do this is we could say that actually, why don't we say downwards is the positive direction, in which case gravity is positive and the speed it hits the ground with at the end is positive. You can set it up the other way and you'd get the same answers, but it's the minus signs that are going to make the big difference here. So I'm happy to do this two ways, depending on how you've taught or how you visualize this. So if I imagine that the downwards direction is positive, then when it's originally thrown upwards, it's actually got a negative speed to start with. So we can think of that. And if you resolve it in the upward sense, then everything going downwards would be negative. Okay, so I'll tell you what, yeah, we'll do it the positive way round first, and then I'll backtrack and explain what I mean. So if positive is upwards, then U is positive because it's being thrown upwards. And if we look at what we've got, S, U, V, A, and T, I'm trying to find U. Acceleration is downwards, it's gravity, and we call that G, so it's minus G, okay? Gravity, let's be careful here, is we're going to have to take a rounded value. Some exam boards want you to use 9.8, and other exam boards want you to use 9.81 or more exact, but we'll use 9.8 for this. To denote it kind of in an exact-ish way, we would use G. So minus G, because it's acting downwards. And actually the final velocity then would be minus 17.5 because it's hitting the ground and it's traveling downwards. And that takes t seconds, and that's from where it's landed is actually how far from where it started. Because there is more information than we think. It looks like there's a lot of unknowns here, but it actually is telling us some crucial information. What else can I fill in? What else do I actually know? So I'm looking at the motion from start to finish. Unfortunately, I don't know the time that's happening. Do I know S? What is S? Any ideas? What is S? And I will clarify some of these points about the direction because this is really important. We do know the displacement is minus 10. So if I look at it from the start, what's happening upwards? Upwards is the positive direction, downwards is the negative direction, and we chose to set that, okay? So if positive is the upwards value, it's got a positive initial velocity. Acceleration is always happening downwards. It's always actually gravity is causing it to want to accelerate downwards. And it ends hitting the floor at a downwards velocity, and it ends downwards below from the point it started. So what we do is we look at the direction of what each of these things are happening in. And the ones that are vector values, which means they're values with a plus or minus associated direction, we have to be very careful on if we set it as plus or minus, okay? So it's accelerating downwards, and that's the same direction that it ends up hitting the floor in a downward sense. So both of those are negative because they're opposite to the way it was thrown, which we've set as the positive direction. Excellent. Really good comments, and we're doing exactly what I wanted here, which is teasing out these tricky bits. So U is going to be the positive upwards initial velocity that makes that work. So if I plug this in, I've got S, U, V, and A. I'm going to use V squared equals U squared plus 2AS. Okay, so minus 17.5 squared equals U squared, which I'm trying to find, plus 2 times minus 9.8, which is minus G, times minus 10. Okay, so I'm going to kind of evaluate all of that, rearrange, and then square root to get U. Okay, has anyone done that? Has anyone got a value for U? So we're going to do, right, so what we get there is that will become 17.5 squared. Let's have a little look what that actually is. 17.5 squared, 306.25. And it will be positive because I've squared a negative. So U squared, and then we've got what we've got. So positive 98 times 2. Let's just double check, and then we're going to divide that, yeah, by 100, and we're going to minus 196, and then square root. So we get U coming out as absolutely 10.5 meters per second. Okay, now, if you struggled visualizing that, I'm skeptical here about explaining it a different way because I don't want to put people off if they got that. Right, S isn't 0 overall for this one because it wasn't projected from the ground, but a really good point because sometimes that is the case. It was projected from a point 10 meters above the ground. So it's actually ended up in a negative position. But thanks for that comment because that actually often is something we need to pay attention to. So S is minus 10 because it's like 10 meters down from where it started. So it has overall been displaced, like as if you're on the edge of something and you threw it up, but then it went back past where you started. If I said find the velocity when it's in line with where it was thrown, then S would be equal to 0. And likewise, if it was projected from the ground, that would be right, S would be 0. So hopefully that makes sense, because it tells you it's 10 meters above the ground to start with. The ground is actually a displacement of -10. So hopefully that's clear. The other way we could think about this is if we thought about the negative as being the positive direction, then S would be +10, U would be a negative value, V would be +17.5, and the acceleration would be +g, because all the things that are happening in that direction are then positive. And what you'd get out here would be, you'd still get the same equation. You'd still get 17.5 squared equals u squared plus 2 times 9.8 times 10. All the negatives would cancel to form the same equation. Okay, so it is just a case of visualization. I hope we've been able to clarify a few of those points as we've moved through it, because this is actually a particularly tricky question. This is the kind of question that, particularly for those that haven't done much of this in physics, that haven't seen this side of kinematics before, they haven't done many problems with gravity, there's a lot of things we feel like we're keeping track of here. So don't worry if you think I need to actually really clarify, why is that a minus? Could I have done it this way? Please do ask those questions, because it looks brilliant in the chat, the things you've commented and picked up on, and it is worth checking and clarifying that it's all clear. So very well done. Yeah, I mean, the mechanics content is very like physics at times. It is essentially, there is a bit of an overlap, which for some people is great, and for others it might be unfamiliar territory. So we just got to work through it carefully. There's a big breadth to the A-level maths course, so we've just got to kind of be aware of that. But we do all need to know it. So that's great. So any questions, keep them coming in. But that was good. So that's that bit done. Right, so now moving on. So this is the same question now, except that we found U is 10.5. So I can use that. I can bring that answer, carry it forward. And this question's asking find the value of T. So we want to find the value of T when it hits the ground. So what we've got, let's do our S, U, V, A, and T. And again, let's think about what we have here. So if we maybe say the downwards direction is positive, so we can not have to deal with too many tricky negative signs, that'd be great. Absolutely, yeah, I'm going very quickly here. I'll give you guys a chance to have a little think about this. But you remember you've got your value from the previous slide, which was U is 10.5. So absolutely, have a second to think about this, and then I'll slowly start working through it as well. Feel free to submit your answers in the chat as well. I think that's been really nice to see some people kind of really working ahead. But absolutely, give this a go. So think SUVAT, what have I got? What do I want? And work it through. Cool. And there might actually be different ways you approach this one. This is a good question where actually you could do it in different ways, but hopefully come up with the same answer. Right, you don't have to split this into two phases. That's a really good question, because we ultimately know all the information that happens by the end of the one motion. It doesn't start doing something different, okay? If, like the previous question with the different posts, we only had information up to B, so we had to use that and then carry it forward. Here, we do know information about right at the end. So it's following one single sort of set of, you know, variables. So you don't need to split this into two phases, because we don't actually know things from the in-between phases. I think if you're thinking about like the maximum height, we've not been given any information on that. So that would potentially make it harder. Cool. Right. So let's have a little look. So some people are coming up with answers here. Let's check if we agree. And then I'll start to work through this. So various ways you could approach this. You could use your previous answer, but do be careful. Okay, it is tricky. So if you've not seen the SUVAT equations before, this will be, very confusing because you might not recognize even what the equations are and how to use them. But what we're kind of stressing is that the direction aspect with negative signs is a really underlying thing. Knowing the equations is one thing. I mean, if you've got your textbook handy or a formula book from your examples websites, you would be able to see, oh, they give us these equations. We just need to work out which one to use. Above and beyond that, I think if you're struggling with what to do ask the question about why have we done it this way. Right, so let's have a little look, because this might need us to work through it carefully. So one way of doing this, we know S by the end of it is -10. Actually, if we're doing it in the positive direction as downwards, then S is 10. It ultimately travels 10 downwards. Its initial velocity, so here it is 10 meters up, it lands there, goes like this. If that's +10, it's initially projected in a negative sense with -10.5 as u, because we were throwing it away from the positive direction. V, we know, is in that direction, and gravity is in that direction. So, and also we're looking for T now. So we've kind of got everything. So there's a few choices we could use here. Excellent. No worries. And if this is new to you, then absolutely it's great for a bit of an insight into what is coming up at A level. And it may be that you've not covered it in physics, you've not covered it in maths, but feel free to try and work alongside these where possible and ask the questions. So what we can do here is, I think if we even used V equals U plus AT, then we know 17.5 is equal to -10.5 plus 9.8 times T. Add 10.5 to both sides and then divide by 9.8. So 28 equals 9.8 T, which tells us that T is equal to I believe 2 6/7. So it's 2 6/7 seconds. So well done if you got that. Now I do want to stress here, you don't have to have used the V equals U plus AT. I spotted in the chat some people have used different values and still come up with the same answer. And arguably maybe not using U is sensible because you don't know, you might not be 100% confident that your part A answer was correct. And you might go, I want to use S, V, A, and T. And so the other SUVAT equation you could have used is this one. Now, a half AT squared. So some people did that. Or UT plus a half AT squared. Good, you could have used that as well. We had options because we had all the other things. Okay. But I think the thing we just need to be really clear on, and I think is the heart of where the problems lie with these questions, and is a struggle for people all the way through to year 13. It's something we really need to think carefully about, is the direction. Okay, what am I setting as a positive sense? And what in turn is going against that? So if I say, right, looking at the ground from this 10-meter height, I'm saying that's the positive direction. So if it's accelerating that way, it's positive. If it hits the ground that way with that speed, that's positive. But if I threw it the other way to start with, then that's going against what I'm setting as a positive direction. So that speed has to be minus. Okay, you could have taken the upwards direction as minus, and then that would have been plus, and they would, taken it the other way around, and then all the signs would change, but they'd all ultimately cancel out to give the same answer. So hopefully it's clear like which ones are opposing each other, and therefore that dictates with the plus and minus sign. But you have to kind of firstly set up which way is positive. Why is S 10? S is 10 because if I say it's the positive direction is downwards and it's initially 10 meters above the ground, and I'm putting the positive direction as the towards the ground direction, then when it hits the ground, it's moved, it's been displaced by a positive 10. So it's moved down by 10, So S, the displacement, is 10. Does that kind of clarify that for you? So because I set that as the positive direction, that's how I know S, because I'm looking at the whole motion up to the end. So I used the displacement at that point, which was S equals 10. Is that all right? So velocity is a vector quantity. It has to have a sign. It has to have a plus or a minus. Okay. Time doesn't have a plus or a minus. That's a scalar quantity. But velocity can be positive or negative. And that is crucial to this question, because if you treated every velocity as though it was all in the same direction, then they'd be throwing the thing up and it would never be coming back, because it would just keep traveling with that velocity. So you have to account for the fact that the velocity is going from plus to minus or minus to plus, however you've set it, because it starts traveling against the way it was initially thrown. Okay, it's a very difficult idea, and thanks so much to those that are asking the question and teasing this out, because this is something that even, you know, in school, we don't do as well sometimes, because we're rushing through the questions and we can't all, you know, engage at the same time and interact and ask the specific questions. So keep that happening, because that's brilliant. But this was a particularly tricky one. We'll keep going because we're exploring some similar ideas here. So here we go. A firework rocket starts from rest at ground level. So this is coming back to a comment from earlier. What's the starting position? Is that important? Yes, absolutely. In the first 3 seconds of its motion, the rocket rises 27 meters. The rocket is modelled as a particle with constant acceleration. So we know it's the SUVAT topic. Find A. So what I'm going to do is I'm going to give you a chance to have a little think about that. And as always, my advice, S, U, V, A, and T. What do I know and what can I fill in? Okay. So this is a part of the mechanics applied side of the course for A-level maths. For all exam boards, we'll cover kinematics, and all the exam boards will specifically look at SUVAT. So this is important that we all do kind of get to grips with it eventually, because it will grow in year 13 as well as a topic. Right, so let's have a little look. So A, some people have gone about it and maybe started finding values here. So looking for the value of A, and then part B, we're looking for the speed after 3 seconds. Cool, so let's just start, even if you're working ahead of me here, by filling in what we do know. So it rises 27 meters. So I'm going to probably set the upwards direction. That's positive. It doesn't actually really matter because we're just looking at what's happening upwards. So S is going to be 27, well spotted. A is what we're looking for. Time is 3. And what other things do we know? We also know U. What is U? What would U be for this question? Is that something I didn't really highlight? So at time 0, the rocket wasn't already doing something. It started from scratch. So it started at 0 meters per second, then took off. So then it increased, it accelerated, and we're trying to find the rate at which that acceleration is happening. Lovely, good. And these little bits of the questions, the words, are what we've got to tease out the meaning from. So superb. If you've noticed, this is S equals UT plus a half AT squared. We can start filling in. 27 equals 0 times t. Well, that's easy. 0 times 3 is 0, plus a half times a times 9, 3 squared. So 27 equals 9 over 2, or 4.5a. So I believe then that tells us that a is equal to 6 meters per second squared. Do we agree with that? So that was A. Now we've got A. Lovely, super, that's good to see. So now that we've got A, we can go on and do part B of the question, which is asking for the speed. And we're going to think velocity for now, the speed of the rocket 3 seconds after it's left the ground. So it's the same information we've got. And what we could use here, I suppose, if you're reluctant to use, I think we're really going to need the previous answer, it'd be handy. But you could use V equals U plus AT. we're looking for v in this question, final velocity. So that v is equal to 0 plus 6 times time, which is 3. So absolutely, and well done if you've got that already. The speed or velocity is 18 meters per second. Okay, so speed should really be only a positive value. So if you find the velocity is negative ever, but the question asked you about speed, you just turn it positive. It was fine for this one because it was positive anyway. Yeah, exactly. Yeah, you could just do that. It's just absolutely fine. You could just do that quite straightforward. But it's showing how SUVAT, you know, even sometimes if it's more complex than it needs to be, will still cater for the easier questions like that. But yeah, really good point there. Cool, right, let's keep going. So here we go. So after 3 seconds, the rocket burns out. The motion of the rocket is now modeled as that of a particle moving freely under gravity. So what is this telling me? What assumption or thing can I take from this? That is actually telling us something very specific. Freely under gravity. What do I know now? Yes, I know the acceleration. Okay, the acceleration downwards is 9.8. Remember a minute ago, or not a minute ago, a couple of seconds ago, it was accelerating upwards. So that's also a consideration we need to just be a little bit careful with. So what we've got to do is the other thing that's easy to forget is that at 3 seconds, there's the ground, at 3 seconds, it's already 27 meters up, okay? Because I'm looking ultimately for the height of the rocket above the ground 5 seconds after it's left the ground. So once the fuel burns out and the motion changes, and someone was asking about this earlier, what do you do? You have got to be careful here because it starts doing a different thing. For these 2 seconds, you've got to find out what happens. But we have to remember that because the question is asking us from the height from the ground, we need to know it started 27 meters up, the change in its motion. So T is 2 for this bit of motion, absolutely, and very well done there. So from time T equals 3 up to T equals 5, let's look at our SUVAT scenario now, okay? And what we've actually got going on here is that we've got, what do we know? We know that A is minus 9.8, T is 2, U, the initial velocity for this period is not 0. And it's very easy to think that because yeah, absolutely. In the previous part of the motion, it was the ultimate value of U at the start of the whole journey is 0. So it's actually, when we're kind of halfway through the motion, the speed it was literally just doing is now the new U value for the bit of motion it's on now. Does that make sense? So if we backtrack, that value was 18. So this is really weird because although we're calling it U, it's happening a bit of the way through the motion. So the final velocity of what it got up to before the fuel burned out becomes the new initial velocity. So when the fuel runs out, it is actually going at 18 meters per second. It's not at rest. It's not like stopped or hit a maximum. It's traveling at 18, and we knew that from part A. So if I treat 18 as positive, I have to treat 9.8 as negative because it was still traveling upwards at that point. So it's now accelerating towards the ground. So it depends what way you see it, but the sign of this has to be different to the sign of this. Okay, excellent. So then we're looking for S for these 2 seconds. So S, U, A, and T. So what I'm going to do is I'm going to say that S is equal to 18 times 2 plus a half times minus 9.8 times 2 squared. And that is actually just a plug in and calculate. You haven't even got to rearrange it. And what value have we got here? What value do we get coming out as S? And then we need to think about what we've actually found. What do we get as S for this bit? Right, okay. So we get 16.4 meters, but that's not your final answer because we want how high it is from the ground. So in those remaining 2 seconds where it's about to fall back, let me just draw it. In that remaining 2 seconds, it's gone up another 16.4. So absolutely, we have to plus 27. So we plus 27 and we get 43.4 meters above the ground. Okay, so this was an interesting one because there were 2 different parts to the journey. This was a multi-step problem, although the earlier parts in the question did sort of scaffold you towards what you had to do. No, well, ultimately it is coming down, but in those 2 seconds, it's still going up. It's accelerating down. Gravity is now pulling it down, but it's not had enough time to make it. It doesn't instantly start falling. Okay, if you throw something and it's on the way up, and maybe you're traveling upwards, it's a bit like, you know, when you see videos of people with a parachute and they jump out and then they pull the parachute and it looks like they go up. They don't go up, they just don't go down as quickly, but the cameraman is normally going a bit quicker, so it feels like they go up. But you're never going to, you know, jump out of a plane and then start traveling upwards. You're just going to, when you release the parachute, stop falling as slowly. It's a similar concept. So what's happening here is the thing is traveling at 18 meters per second upwards, but the fuel's run out. So for a little while, it's still going to travel upwards, but ultimately gravity's doing its work and it will hit a maximum point and then it will actually be traveling downwards as well. But from the point the fuel burns out, G is the acceleration, like it is accelerating downwards, but there's a part of that motion it's still going upwards. So a bit like the question where we threw it up and then it came back down. It was accelerating down the whole time, but for a small part of the motion, it was moving up. So hopefully that's clarified it. Yeah, the rocket is still going up and that's why we add it. So it's that little bit of time, that little window where the fuel's run out that was pushing it at a really quick speed upwards and the speed is just getting less, but it's still moving up. So that's what's a bit weird. That's why we have to add the displacement. But I hope that's kind of clear. And I think we've got another question we can look at here together. So 3 posts, P, Q, and R, are fixed in that order at the side of a straight horizontal road. So the distance from P to Q is 45. The distance from Q to R is 120. A car is moving with constant acceleration. The speed of the car as it passes P is U. 2 seconds later, the car passes P, it reaches Q, and then the car passes R 4 seconds after passing Q. So just to kind of draw that out, P, Q, and R, what we've got, hopefully you can see that and I'm not blocking it. Yeah, cool. So this distance is 45 and this distance is 120. Now these questions, I've seen so many people overcomplicate this, mess it up and so on, and they think, oh, I need to do something with here and I need to do something with here, and actually that's where we're going to go wrong. I think what we need to do is actually look at what information is given, because a lot of the time we do from here to here and we also use the whole journey as well. Okay, so find the value of U. Let's write what I know. Let's write my SUVAT bits out. And there are going to probably be 2 equations to keep track of, absolutely. But we need to make sure we get them right. Yes, I will give you some time because I'm going too quick now. So a couple of minutes, absolutely. Think about this. And I think this is a really good question because it's an easy one to overcomplicate. Okay, well done, and really well done today to everyone that's worked alongside that so well. And that can be sometimes quite tricky to motivate yourself, especially for a topic that's maybe unfamiliar or we don't like as much or we haven't done as much of. So really well done. But I'll give you some time there, and if you want to share what you've done in the chat, feel free, but I will go through it anyway. And that's great. Brilliant, some suggestions coming in. And I would say that I do agree with that. I do agree with that suggestion there. But, you know, people are working at different paces here. They might be at a different stage. You might be not quite there yet. You might be ahead. But yeah, there are two parts of the journey to consider carefully. So very well done if you've picked out those two parts. And I think the bit that's disguised in the question is that actually we're told 4 seconds after passing Q. So what I actually know is for the whole journey, what's that displacement or distance and how long does that take? Right, this is hard, this is tricky, and this is one I've seen so many times, questions in textbooks just like this that have thrown people because they're trying to really deal with the wrong bit of the question. You are given enough information, it's piecing it together. So yeah, don't panic. Yeah, absolutely. So the two steps we're going to have to consider here are from P to Q, and actually it's easier to deal with P to R than it is from Q to R, which a lot of people do. So from P to Q, what we've got going on is we know S, we know we're looking for U, we don't know A, but we know T, and we know like the distance. So what we can put together there is S equals UT plus half AT squared. So 45 equals 2U, because the time from here to here is 2 seconds, plus a half times A times 2 squared. Then from P to R, welcome back if you've left, that's fine. So from P to R, and I'll answer some of these questions as I get through this one, because there's some good points being raised here about kind of comparatively how difficult this is. But this is a really crucial topic, so that is something that is worth bearing in mind. So here, S is 165, and it's easy to get that wrong because we're going from P to R. And U is what we're looking for, but T would actually be 6 seconds because it's 4 seconds after it reaches Q. So you've got to add the 2 times up. So U times 6 plus a half times A times 6 squared. And so your two equations, as previously mentioned, are 45 equals 2U plus 2A. Now these sort of simple simultaneous equations, I'm saying simple, you still need to be careful here, but something I will point out is that if you have the newer calculators that are allowed for the A-level, the class Wiz or equivalent, they actually solve these simultaneous equations for you. So there isn't really an excuse to get that wrong, given that that is an allowable piece of kit you're allowed in the exam. Okay, so we should have got U equals 20 meters per second. Well done if you did, and A equals to 2.5 meters per second squared. So very well done if you've got that. And even if you didn't, hopefully you'll be able to work towards that and get there. I think it was a really worthwhile question doing though, because I've seen this style question cause so many issues in the past. So that was good. In answer to one of the previous questions about how the difficulty relates to the A-level as a whole, I think the big challenge with the A-level, other than the overall difficulty is quite a jump up from GCSE, is that actually there's such a breadth to the content. So the applied is quite different. This is very sort of mechanics, physics based. The statistics is very different again, and the pure is complex enough as it is. So excellent, well done if you did get this. I think that's a consideration in terms of the A-level. People have different strengths, and that's what makes this tricky. Some people love stats, struggle with this struggle with the mechanics or the pure or whatever, but that's why it's challenging. So very well done with those. What I'm going to just quickly mention, which I'm sure you've maybe seen before, is I do just want to quickly share with you some information about the site. Could you please let me know you can still see this? Can you all still see my screen? Okay, so I think I've just shared it so that you can see the Stat Revise site. Lovely. And I just wanted to point out, if you are finding these sessions beneficial, there's web classes happening all the time on Stat Revise, going through all the A-level topics. So there's also drop-ins that I'm running. So if you've got just an individual one-to-one question, could we please go through this, whether it's from homework, something you've covered in class. These are all really useful, and you can actually go back and watch previous ones as well, which are particularly useful for the web classes. And I'll share a coupon code with you in a second, so that if you are interested in this, in our site, in this resource, there's a discount code I'm about to share. But I just want to really stress, for those that were asking about the A-level, particularly, and how challenging it is overall. As I've said before, resourcing yourself is really important. And the problem is, a lot of the resources online are geared up for the old A-level. This is still a relatively new A-level, and everything on the platform on Snap Revise is targeted to all the different boards, to all the specifications that have been updated since 2017. So there's loads on here, diagnostic quizzes. The whole course is broken down into really manageable parts with lovely clear notes that you can just download and have access to. So it is very tailored to your courses. And I think really giving you an opportunity to do really well and get the help on the topics you need it on, not just generally a load of stuff you've got to search through. It's all very clear to access quickly. And I think in the name, Snap Revise, it is snappy. Snap Revise, you're able to just get snapshots, quick information on specifically the topics you need. I'm sure you've seen this before, but if not, we'll kind of feel free to look on the website. There's a lot of information on there. I'm going to stop sharing that now and return back to the PowerPoint. So hopefully you can see this still. Thanks very much to everyone that worked through the questions there today. If you found this useful and you'd like to watch some more, look at what we've got coming up, set reminders. There's loads going on for the other subjects. I understand it's a bit of a strange time with the schools being closed. So hopefully you're able to get on and carry on with your work. And I hope you're keeping well as well, because it's a very sort of strange, unprecedented time. But there's lots on the site. There's lots going to be on YouTube. And I'm just going to share this with you today. So appropriately named £10 off discount code for your first month with Snap Revise. If you've enjoyed this session today, do check out the website, see if you think it would be useful for you. But as I said, there'll be these YouTube sessions as well. But that's the code that is going to expire tonight. So make a note if you're interested. Really well done again. And thanks to everyone that's commented in the chat and worked alongside that. You've done really well there. And thanks for the comments. You'll have to explore the kind of different packages if you are interested, because there's kind of different levels of what we offer, but it's all very, as I said, tailored to all the A-level courses. So check it out, and hopefully it'll be something that's useful for you. Very well done again. I'm gonna stop sharing that there. Thanks again so much for taking part, and I hope you all keep well, and maybe see you at one of the later sessions. Thanks. Cheers. Well done, guys. Thank you.